Hello everyone. Hello everyone. Welcome to webinar. Welcome to JACOV webinars. Glad to be here. Glad to see you all here. Today we have yet another webinar. I hope you will like it because we have great speaker and great topic and a lot of registrations, by the way. So thank you very much for trusting in us and register for our webinars. I really hope that you will like it. So just a reminder, we have two chats. One exists on our platform, which calls We Are Community. Link to it you may find in the description if you are on YouTube. And also we have chat on YouTube channel. So you may use both of them. I will monitor both of them to see your questions, see your comments, and see your reactions on our stream. So I see some hellos coming to the chat. So hello everyone. Yeah, nice to see you all here. We just wait for a couple more minutes just for everyone will come to us because they just received the notifications in Outlook. So just want to remind you that we have a community on We Are Community platform. So you may subscribe on it to receive all notifications on our events, which is happening there. We have news articles, we have these webinars. We have a conference which calls Java On, which happened in December, and we had a great talks there. So if you want to check them, feel free to check our YouTube channel. All of them are there, and each Thursday new talk is being released from this conference. So you may check them and subscribe on our YouTube channel. We will be glad for that and really appreciate it. So Today we have a special topic, which is hype, on hype, of course, and this is about which came in previous update of Java in Java 19. Today we will speak about Project Loom, which will be, I think, on trends for some time. And I want to invite here our today's speaker. His name is Aleksandr Filichkin. Sasha, hello.
Hi, everyone.
Hello, thanks for being here with us. Nice to have you here. So I have a question to you. So you have a Medium blog, and often we talked about your blog here because you are I would say the only person I know who made the comparison of different features of Java, how they work and how they work in cloud. Why you do this?
Why? Actually, to be honest, so sometimes even on the project, I need to know what tools should I use, maybe like technologies, and I'm trying to Google it. This is what how the first blog was created, and I didn't find any useful information, and then I made this test and decided to share with this community, right? And then when you have one article, you want to get new one because if you have a lot of reads, it's like quite interesting stuff. Every day at first you like go and see the stats, etc. New questions. So to be honest, I like it. Yeah, and I'm trying to discuss like the most interesting topic for me. So nobody pushed me to write it. Only what I want. And
so guys,
this is the topic what we definitely need to discuss.
Yeah, for sure. So guys, I will share the link to Aleksandr's blog in both of chats. So if you haven't checked it, please check it after our webinar. There are a lot of nice articles regarding comparison of how Java works in cloud, of how Loom works in cloud, and I think Alex will today share a lot of insights of that. So I think everyone is here, so we don't need to waste time anymore. So Sasha, I would ask you to share your presentation so I will be able to put it on the stream.
Okay.
So guys, while Alex is sharing, just a reminder, we have two chats, as I mentioned before. So one of them is on our platform, We Are Community. Another one is on YouTube. So both of them, I will monitor both of them. Please type your questions there. And all your questions, I will, not all of course, but most of them I will try to ask Alex when we have time for that. So just type your questions there, type your comments. You may have discussion there. I really encourage you to do so. Okay. I think, Alex, that you shared your own screen with StreamYard because I see this screen with StreamYard itself, not your presentation. Meanwhile, guys, you have a few moments to have a cup of water if you haven't yet. Just to check that you are ready for our webinar today.
What about this?
Yeah, now it's good. Now I see your presentation. Okay, so I think we're good to go. Good luck to all of us. Alex, good luck to you. Let's start this webinar. Let's go.
Yep. Thank you, Roman. Yeah. So first of all, thank you everyone for joining. I hope you will be happy with this presentation. So as you already know, our topic today is the Project Loom and how Loom, I hope, will change our life, at least for Java developers. Okay, a few words about me. So my name is Aleksandr Filichkin. I am Chief Software Engineer 1 here at EPAM. I'm a technical lead on the London Stock Exchange project, 11 years of Java experience, AWS fun, and as Roma already mentioned, I have technical blog. Okay, let's go to the business. So we have very popular common task for Java backend developer. So we need to implement some REST service, microservice that will save some entity into database and should validate some address. So in our case, we're going to use some person entity. And for address validation, we have some separate microservice or REST service, get endpoint, which we should use to validate our entity. Okay, and here is the first solution. I believe this is normal Java developer will start, will go with this solution. It's like Spring Boot, and you just have some post method in controller, and we have the first line is to send request to some address, get this status of this address, is it valid or not? So we have a boolean. If it's valid, we just save in database. We have some repository service or layer, and we just save it. If it's not valid, we just return some exception. Right? It's, I believe, it's the most common solution. Of course, you must to refactor it, move to statics, etc. But we are just to simplify it, we have this. Okay, and everything looks fun. Yeah, it's looks like very easy, right? Too easy. And then, okay, and let's discuss how it works. So if we start this Spring Boot with default settings, by default it's use Tomcat, and Tomcat has a thread per request model. So it means, so we have a lot of clients. So our normal clients is from UI, mobile, doesn't matter. For every request, we need a dedicated thread, and these threads usually are stored in thread pool. Like, do not create every time new thread is just pulled. And this thread will process our business logic. So in our case, it goes to some controller, and then this request goes to some blocking resource. For example, for validate endpoints, what we're using. And here, this request will be blocked, and we'll wait for the result from this address service. It blocks this thread, and it means that if we have a lot of requests, every thread will be blocked and wait the response from the blocking resource. So it can be another microservice, database if it's slow. So it can be any kind of resource. Yep. And since we know about this thread per request model, I just want to highlight how it works under the load. So as I mentioned before, let me open this. Yeah. So to simplify our test, okay, guys, maybe I should zoom it a bit. I forgot about it. Yeah, this service address, I already have local this service. It started. It always returns the response in 1 second. So we should expect that our save person method should be processed at least at 1 second and a few milliseconds to save this entry in database. I'm using PostgreSQL. It's normal stuff. And yeah, I just want to highlight that I have a Jmeter test, and we are going to test our service. We just sent 200 requests to our service, and we're expecting that the response is about in 1 second. Okay, let's quickly start it. So, okay, we have it. So as you can see, we have average response time 1 second. You see this maximum, almost the same. So the throughput will be about 200 requests per second because we have 200 parallel requests and everything looks fine. This is how you can see, for example, you write your service, everything is okay, make this test, and you're happy. But one day you will open your Outlook, your mailbox, and can see that there are a lot of user complaints about this timeouts, slowness on your service, etc. So, and first of all, usually, like normal developer will think that maybe the problem not with our service, but with some address service, and address service like responds slow, and that's why our safe method also takes too much time. But for example, you go to address service, and in metrics we see that this service is okay, it's always return 1 second, but our service really works slow. Yep, and to prove it, for example, we are going to send 300 requests per second. We also expect that average response time will be 1 second, but we can go and see that average response time is 1.5 seconds. Yeah, why it happens? So the problem that I cannot communicate with audience, then I will answer. The problem that okay, let's open our presentation. That thread pool is limited, and by default it has 200 threads. It means that we can process 200 requests in parallel. If we have more, all new requests, like the latest request, will be blocked and wait for the free thread in thread pool. Yes, like the simple solution is to, like, this is default and good, like fast solution workaround just to increase the number of threads. Like in Spring Boot, you can just increase it to 400 requests, for example, and start it. And it will solve your problem. And now you can process 400 requests in parallel. But for example, in my life, like several years ago, when we had this some kind of service, we even increased to 5,000 requests, and this even value was not okay because sometimes response from underlying service were like too slow. Yeah, and now we understand the main problem of thread per request model. That yeah. Let's first of all highlight what is good. So it's easy to code, right? So like very straightforward solution, easy to debug. We have a good tooling. You can make the breakpoint and get everything. Yeah, we have a good tooling. We have a good libraries, for example, like for database, for everywhere, and for everything, like Hibernate, etc. Like in Java, it's not a problem at all. Yeah, and what is bad? So the bad that solution is not scalable. What does it mean? That yeah, I just want to one more time highlight something that's very important. So I don't want to have it at all. So that's we have like Spring Boot. Let's first of all, I just want to open GVisualVM and profile and show you that why it's not scalable. So this is our service. Okay, as usual, GVisualVM doesn't want to start. Okay. Yeah. Let's load our service. Like how many requests we have? Okay. For example, this one, 300 requests, and we can see that we have 200 requests. So CPU is slow. And if you want to scale it, if you even send like 500 concurrent requests, you will see that CPU is slow, memory is okay, but we have a big delays, right? And the problem, even if you're in cloud and you're trying to solve it, you have a lot of free resource, you can process any load. You don't know how to scale it. Yeah, because resources are okay, network, all parameters are okay, but it works slow. Yeah, this is for me. This is why it's not scalable. The solution. Okay, let's stop the meter. Okay, move to our diagram. Yep, and yeah, we already checked that we can just increase the number of threads. This really works. But the problem is that the threads are heavy, and you cannot create as much thread as you want, because the threads, one Java thread, it's operation system thread, and by default it requires 1 megabyte reserved stack memory. Context switching is slow, so it means that if you have like your laptop or like your EC2 some node, it has like 2, 4, 8 cores, but you can create 10,000 threads. And context switching is how your operation system switch this, distribute the load between these threads. This operation is not fast. So if you're talking about like 1,000, 2,000 threads, it's okay. But if you have 1,000,000 threads, it's like a big deal. Okay, and even thread startup time is 1 millisecond. If you have 1,000,000 threads, it's like too slow. Okay, guys, and now you understand the problem of Tomcat thread per request model. It's like a very old issue, well known, and the solution currently, like almost all like services where we need like high throughput and a lot of I/O, usually use asynchronous, reactive, non-blocking implementation. It can be different libraries. For example, this is solution using Reactor with Spring Boot and WebFlux. So as you can see, we have the same logic here, but code looks a bit different, right? So we have the same some HTTP client, send request, then we get the result, then we get from result some serialize this result to Boolean, then we filter. If it's true, then it go to flat map, and then we save something. If it's not true, it will not go to the next chain. You should go use method like switch if empty. If it's empty, throw some exception. Yeah. What's the problem with this solution? So the problem is it's like a huge API change. So if you already have a big code base and you have like the problem only with some save person method, but you have a lot of methods, everything works fine, but only one method has some communication with external service, it means like all your code should be re-implemented, changed. And this change is not trivial, right? You see the difference, what we had before and now. It's completely another style. It's like functional style. It's very different. Okay, what else? So clients and libraries must be reactive, but at least asynchronous. So what does it mean? It means if I have some method repository layer and I want to save the person, it should return some callback, like future, mono, some kind of promise, but it's not a real result. Okay, so the next problem is stack trace. So with this solution, stack trace is not good. It's if you have some problem, it's quite difficult to understand what was the flow and to investigate the problem. It's like very common problem in reactive life. Yeah, if it's difficult to return debug, maybe it's even the biggest problem. So if you don't have experience with some reactive libraries like RxJava, Reactor, etc., it's quite difficult. The first time it's very difficult to write like good code. You don't know this API, a lot of new methods. It's very difficult. Yeah, and the latest point is the most critical for me. That's if you have let's assume you have like web client, you send HTTP calls to validate your address, but now there is some new implementation, and for address validation, you must to use some library, external library, what was implemented by another team, let's assume, and this library can validate and return true or false, but it doesn't return any promise, it just returns it's like blocking. And if you want to, and it works by under the hood, it maybe you can use some web client, etc. But you must use this library, and this library return just a blocking result. In this case, if you switch from Tomcat to native with mono, WebFlux, etc., it will not solve your problem at all. So you have the same problem. Now you have to run blocking code. You can you run it in some thread again, but you just come to the same problem what was before. So it means that if you have a blocking library what you must to use, reactive WebFlux will not help you at all. So that's why I think like we need something new. Okay, and what we need? We need imperative simple code but scalable, right? So like the normal Tomcat code, like very simple but scalable. And that is why Project Loom was designed. So I hope now, guys, you understand what is the problem and why Project Loom was created. Okay. Yeah, just a few words about the Loom. So the most important thing is still preview feature since Java 19. It's not something new. So in 2017, Ron Pressler introduced, he did some POC with, it was not Loom, it was fibers. I remember this good presentation, and he explained the problem, but nobody believed bonus that it's possible to implement. But fortunately, now in Java 19 we have. Yep, and the summary goes on is almost the same what I discussed before. With virtual threads, you can implement thread per request style service, which is scalable, efficient, and virtual thread is some kind of normal thread, but a lightweight version of it. So, and you can use the same API, the same code, do not modify anything, it should work like very fast. Yes, a very important thing here that this is a very huge change. So as you can see, there's more than 1,000 class in Java, in JDK was changed. It's not like it was introduced in JDK and a lot of methods were changed. And I will show you what some most important changes here. Okay, so let's see this sample. This is like the solution where I try to create 100,000 normal threads. It's normal thread, not a virtual thread at all. Sleep inside this thread, waits until all the threads are processed and collect the time. So it means we started 100,000 threads. Every thread should sleep and waiting until all this processing will be finished. So in Linux, it failed with out of memory exception error, and it was able to create only 7,400 threads. And yeah, you can see this memory was not enough to create it. And yeah, so it means even with solution with Spring Boot, what we discussed the first time, you in Linux, it's like small EC2, but you cannot have a lot of threads. So there is some special parameter what you can update a bit and maybe reduce the size of stack, etc. But still it's limited by operation system. Yep, on Windows, to be honest, you can see that it's maybe also not possible, but to be honest, I was able to start 100,000 threads. It took for me like about 3 minutes. I even was able to start like million thread and sleep here not 10 seconds, because if you sleep not enough, this thread will be like it sleeps, then it's active again. This thread will be reused. I like sleep for I don't remember 1 hour. It took like more than a day, but I was able to start million threads. But it's for in Windows, so and it's very inefficient. It's very slow. Okay, let's see what we can do with virtual threads. So the API almost the same. We start 100,000 threads. We create some runnable, but now we have like new useful method like threads of virtual and pass the runnable inside the thread, and it will start the thread. So the same thread, nothing was changed, just new way how we can create a thread. Okay, and the result that on Linux, on Windows is you can easily start all this stuff. And for me, it took 13 seconds, but 13 seconds because 10 seconds it just wait. So it's about 3 seconds, 3 minutes, 3 seconds. And I was able to start 10 million thread on my local machine. It's normal, like 8 cores. And yeah, more than 10 million, I had some problems. So but 10 million was okay. Yeah, this is the goal, like, of Project Loom, that you can use the same mostly code, but you create as much threads as you want, and it works well. Okay, so let's move and try to change our code to Project Loom fashion. Yeah, so this is what we had before. We have a post and points to save everything. We do not touch at all this code. And now we just need to add 2 new like beans in Spring Boot to override some request processing. So now we are going to use not a normal let's say task executor, but we are going to create virtual thread per task executor. So in executors class, you know, there we have some like fixed thread pool, cache thread pool, what else? Some kind of thread pool, so for join thread pool. Now we have a new thread pool. It's like virtual thread per task executor. It's almost the same like a cache thread pool, but it creates not every time a new thread, but create virtual thread. Almost the same, but create virtual thread. Okay, I just have some. Okay, and yeah, and the same we need to update for protocol handler. Now we just move this processing to virtual thread per task executor. Okay, yeah. So let's show, let's prove that it works. Okay, yeah, I have to move it to another window. Okay, yeah, this is my controller. Let's stop it. So in config, I just uncomment this piece of code. Now you can see that we have like application new executors. Maybe I should zoom it a bit. Yep, and yeah, I'm going to start it. And first of all, I just want to highlight that if we want to start the Spring Boot like Java 19 with this Project Loom, you have to use enable preview feature, and I have Java Caretta 19 because I'm doing almost everything in AWS. That's why I'm using Caretta. But you can use any kind of JDK 19; it will work. Okay, yeah, let's start it. And yeah, and I'm going to start it, open GVisual as well, and show you the difference. Okay, it was started. Okay, amount of threads. For now, we don't have any load. That's why we have only 23 threads. Now let's load our system. For example, 300 requests in parallel. So we send it, and now you can see that we have only 40 threads. You can see that we have some fork join pool that was created. And yeah, let's check that the result is good. So requests are processing in 1 second average response time. Yeah, so the same will be if I send like 1,000 requests, etc. But the problem that, as you know, in my local laptop, and I don't want to break it. But you can see that we can process it. CPU is okay, memory is okay. We don't have a lot of threads. Everything works. It's like magic, right? That's what we wanted before. Okay, let's move on and see. Okay, how does it work? How does it work? It's like, because it works, you prove it. Let's try to understand how it works under the hood. So actually, Project Loom use new kind of model. It calls NM threading model. So we still have normal system threads, normal thread like thread what we currently have, and we just have like a few threads, usually the same amount, the same number of threads as the cores, and we have a lot of virtual threads. System threads is normal threads, and virtual threads we have a lot of, like 10 millions threads, and this is kind of just Java objects which are stored in heap. Okay, and why we can create million system, why we cannot create million system threads, but can create million of virtual threads, right? That's like very reasonable question. So And the answer is it's stacks. So the different how stacks are processed here. So this is a classic stack. So what you currently use in production is if you have method main with 2 methods inside foo and bar, you have a stack. Stack by default, it reserves 1 megabyte of memory. It's split it into pages, and page usually 4 kilobyte, but it also in some systems can be bigger. And you just process your method. If it's needed new memory in stack, new page will be reserved, will be used. And we have the latest page is just guard page, and it's used to understand if we like reach the limit of stack. And if you have stack overflow error, it means that stack is not enough. It tries to take this guard page. Okay, this is about classic stack. Yeah, and now we are going to, I'm going to describe how virtual threads and stacks are working. So this is like normal system thread. It has already it has a normal stack. And even in stack, we have something because, for example, it's not like a new, it's some method. In some method, you already have something. And then we want to start virtual thread. Yep, it means that in we have some virtual thread and heap, and this virtual thread is connected to stack. So this reference, it usually in Loom they use such word as pinned. It means virtual thread can be processed or can be, if it's in running state, it should be connected to some system thread, and system thread processes all logic of virtual thread. So virtual thread cannot do anything if it's not pinned to system thread, right? And we started a new thread, now virtual thread, and virtual thread is, now we have like system threads that you do everything for virtual thread. Then virtual thread is running, and in running, so it means that inside virtual thread you do some logic. For example, in Spring Boot, we send request, I don't know, we validate something, etc. Just normal logic. It's like inside the virtual thread, but system thread is processing it. This is what we had before. Now we have 2 new pages. For virtual thread, for example, we have some logic, big logic, and 2 pages is needed. And then we have a virtual thread goes to waiting state. But in our case, in our microservice, when we inside this controller and post method, and we need to validate this endpoint, we just send HTTP call. We have like some changes in Java net, and when we send request to some HTTP call, our thread is in waiting state. It's like a normal thread in waiting. It doesn't do anything, just wait. And when virtual thread in waiting state, yeah, I just want to highlight that we have like only 5 options how virtual thread can be moved into the waiting state. It's like thread sleep, thread yield, okay. Later I will explain what is it. Log support park. So log support park, why it's important? Because almost all classes in Java util concurrent use log support park for synchronization. I mean, like reintrant log, etc. They're using this approach. Yep, and also Java net Neo channels were also changed, and they can work with virtual threads and have some special path for virtual thread. And later I will go to this method and show you what was changed. Yep, and now waiting thread is virtual thread in the waiting state. When it's in waiting state, it shouldn't block like system thread. It shouldn't be connected to system thread because it doesn't do anything. And then these steps usually called unpinging. So it means that virtual thread removes this connection to system thread, and the stack of virtual thread, so we have new stack, is moved to heap. So it means that we clean up our stack and it's not needed. we move just this stack state into heap. It's and the virtual threads knows about the stack in heap. And then virtual thread in the pin system thread can process other threads. So now this thread is like normal thread. It can do whatever. It can do some CPU intensive stuff or can start another virtual thread, etc. And yeah, it can do like new stack. It doesn't know about the virtual thread at all. And then virtual thread can move should be moved to the running state. So it means when we send the request to our address service HTTP call, there is some response, and when we have this response, it goes like Java Neo channel will make this thread running again, and now we need to continue processing this stuff. And again, this virtual thread will be pinned to the system thread. All the stack from heap will be moved to the stack of normal system thread and will be processed. Okay, I hope you understand this stuff. So the main goal, the main idea is, okay, let's use this page, that now we can have a lot of virtual threads because every virtual thread is just some object in heap. Heap is huge, and in stack in this heap stack for virtual thread can be different. For some thread it can be virtual thread, it can be small, some it can be big, because it depends on the logic what virtual thread does. And we do not block the system threads, so that's why context switching is fast, because we don't need to go to operation system and ask to like orchestrate our threads, because Java does all this stuff with all manipulations. Okay, just to highlight, the system thread use classic stack. Virtual thread have small stacks which are stored in Java heap memory. Virtual threads are started when virtual thread is started. Stack is copied from heap to the system classic stack, what we discussed before. Yeah, and when the virtual thread in blocking waiting state, the stack copy back from the stack to heap. Okay, and what does it bring? So we can create a million of threads. Context switching is fast, but there is a good article. I will add this link to my presentations, and that sometimes it can be not so fast, but I would say it's like some corner cases. Code changes are small. So for example, for our Spring Boot application, we just need to overwrite one two beans, and everything works, right? It's like easy to adopt existing libraries because like you don't need to touch them almost. Okay, the performance. So no, guys, let's move to a bit back. So I mentioned before that I will highlight how the thread sleep, yield, etc. was changed. Let's just go to this method inside and see what was changed. So we have thread sleep, right? So now if you go to thread sleep method, and if you have Java 19, you can see that there is some special if condition. Currently Java differentiates the difference between normal thread and virtual thread. If you run the thread sleep in normal thread, if it has one path, if it thread sleep in the virtual thread, it has another path. So now we have method, if we can see is this thread is virtual or not. If it's virtual, it has one path. So in virtual threads, it doesn't do the same what normal thread does. It doesn't block. It has a special mechanism. And that's why when I mentioned before, this Java JDK has a lot of changes, because now all methods were written, and we have such paths. So Java just you use the same API, but somehow it understands it virtual or not. This is like a very big change. We have a lot of changes in JDK for almost all this stuff. So the same for thread sleep, yield, etc. They had different paths. So That is why thread sleep doesn't block virtual thread, because it can understand this virtual thread and process another way. Okay, yep, about the performance. So here's the link, and I did some performance test. What I use? So I just didn't use the PostgreSQL, etc. This is a service, was like common service that takes the request, send it to another service, waits for the response, and the response from the underlying service is 200 milliseconds, and return response back. It's like some proxy service. And I did three implementation. First one is Tomcat plus Loom, what we currently have with two new beans. Then just normal WebFlux, and then WebFlux plus Loom. So let me quickly explain what does it mean WebFlux plus Loom, because it's not clear. But the goal of this test was not to compare Tomcat and Netty, because if you're using Spring Boot normal with threads, with Loom, we still use Tomcat, and it's not good test when you compare Tomcat and Netty, because Netty by default is more efficient for I/O. That's why I just started WebFlux as with Netty, but did this blocking stuff inside. So you for example have blocking all service, etc. Now you just need to update only controller in your WebFlux stuff and run your blocking code, but wrap everything into Mono. So, and if you have just your service layer, you do this blocking and just wrap into Mono. And when you wrap it, and you ask to wrap it using some virtual thread per task executor. So it means that you're using blocking code inside the Netty and WebFlux, what is very like strange if you doesn't know about the Loom. And this approach brings it's even better if when you Netty WebFlux plus Loom is better than to use reactive code. As you can see, when we have a huge amount of requests, WebFlux plus Loom is better than just simple WebFlux plus reactor. Yeah, and just want to highlight that here you first three charts we have like Tomcat plus Loom. Here we don't have. In my article, you can see that the Tomcat is not designed for a lot of parallel requests, and it stores too much objects in memory. And on this, when we have 400 requests, I had like out of memory error. I did the profile. It even attached this like there is no any memory leak. It's just how Tomcat tries. It stores a lot of information about the request, and it takes too much memory. But even this result is quite okay with them. Okay. Yep. Now, as usual, when we have something good, we should have some limitation. Yep. One problem with virtual thread, if you have CPU intensive stuff inside the virtual thread, then it will block the system thread and will not unpinned. What does it mean? So if you have, let's assume in normal Java, with normal system threads, you can start like 100 threads, and 100 threads will do some calculation. And you will see that all these 100 threads are doing almost the same in parallel, and thread scheduler will distribute the load, and all threads will close some invocation or will finish this processing almost the same time. But with the system thread, if you have CPU intensive thread, it will block this thread, will do anything, will not allow your another threads to take this free CPU and free system thread, and it's like not efficient. You will expect some another result. But to be honest, it's quite like corner case. It's not like a real normal requirement when you need to do some CPU intensive stuff and expect these threads will be interrupted and another thread will do some processing. But you just should be aware of it. And how to solve it? If you have some CPU intensive stuff, you can just inside this CPU intensive method, add method yield, So normally if you open, I believe normal Java developer doesn't use this method yield, but with virtual thread, it's very good. So if virtual thread sees this method yield, it will unpin and another threads can process it. So it's workaround. I believe it's corner case, not so important, but guys, please be aware of it. Yeah, the second problem that with virtual threads, you can see some performance degradation because virtual thread can be processed on different system threads and even on different CPU processor, and it means that we cannot use CPU caches, because if you like use some it's like in a CPU cache, it's very efficient and it's good, but now since this virtual thread can be processed on different CPU cores, cache can be missed. But the same is happening for Reactor, for RxJava, etc., for non-blocking, because like all this flat map can be processed in different threads. So I would say it's disadvantage, but not so critical, because in with Reactor, with all these asynchronous solutions, we are even, I believe, even do not. It's not maybe something that somebody that even doesn't know about it, and we can ignore it. Yes, now we can expect more memory usage. Why? Because before we had like stack, and this in stack, like stack with system threads, it's not stored in memory in the heap, right? And garbage collector doesn't process these stacks. It's just you finish this method, stack is removed. Now we have a stacks with virtual threads which are stored in the heap, and we can expect a higher memory utilization, which is like, it's maybe not so critical, but it's more critical that garbage collector will be more aggressive, and you can expect bigger CPU load during this garbage collection. Yeah, and now the most, like the biggest problem, that this weird system threads will be pinned inside the virtual thread when we have, so what does it mean? So it means that virtual thread cannot be moved to the heap if it's in blocking state, if you have something. If you have native code invocation, so it means if you inside your, for example, in our REST controller, we have some native code invocation, virtual thread cannot process it. It cannot deserialize this native code into heap and then serialize it back, because reference can be broken. That's why the native code cannot be used with virtual threads. But I believe it's not a big problem, because at least in my experience, native code invocation is like very strange case, very real case. But here the most important stuff, that synchronized sections and methods also cannot be used with virtual threads. If you have synchronized method or section, then these virtual threads cannot be unpinned and moved to the heap. It's like a big problem, because nowadays we have a lot of libraries, even like you can contribute, you have in your code base, it's synchronized methods, it's normal. So first of all, please stop producing synchronized code, use reintrant lock. Yeah, and the solution is to use reintrant lock. Why? Because reintrant lock use this feature of park method, which supports virtual threads. So if you like change your synchronized method to reintrant lock, everything will work fine. And also, I recommend you starting your JVM with this parameter. It will show you if you have some problem and your virtual thread cannot be like moved to the heap like unpinned, then this when you start the application with this parameter, it will show you stack trace with the problem. Okay, now let me show you highlight this problem. So okay, let's stop it. I hope the meter doesn't work. Okay. Yep. First of all, I just want to highlight that this is my Spring Boot application. Okay, I have Spring Boot application is Maven, and in Maven you can see that I'm using some strange snapshot version of PostgreSQL. Why I use it? Because this latest version of PostgreSQL has a fix for rewriting synchronized method to reintrant block. It was merged few weeks before, and okay, the discussion was raised a lot of time ago, but a merge was fixed before. We even don't have any release version, just snapshot. And you can see that nowadays a lot of libraries have a lot of merge requests just to get rid of synchronized block and use reintrant block. It's like big, I see a lot of requests for all the libraries because everybody wants to support Loom. Yep, and that's why we had we run our services and it worked fine because it has some fix. So if I remove this Postgres SQL special version, it will use version 5, as far as I remember, by default. You reload the project, and I will start my Spring Boot with this option, trace pin threads full. Then let me start my Spring Boot application. Okay. Okay, application started. Now I have just method to test it. I'm going to save this my request. I've saved it. I'm saving it. Okay, and now we have exception in the log. This why we have exception because we pass this JVM parameter trace pin thread, and now we have a log, and we can see where my where this virtual thread was not able to move to the heap, like unpinned. And we can go to some method and see that this method is synchronized. Method is synchronized. So we have method synchronized. It doesn't work. And if we start our application, let's start it. So we have started. I just want to start just with GVisualVM and show you that there is a big difference. Okay, this is something old. Let's close this old one. So if we have this problem, it's like very big problem, and you can see sets. Okay. Okay. Let's load our service a bit. Okay. Is it running? Doesn't work. Yeah, and you can see that it works very slow. This throughput is very bad, right? So it doesn't. Its average response time is big, and it doesn't start new threads. So, and it's better because the system synchronized method is inside. It doesn't allow to use this virtual thread, and that's why we have this. So that is why important, very important, to start your application with this parameter to see where this system threads, where you have this problem with synchronized. Yeah, the same if, for example, I want to use like synchronized keyword, like new object. So it means I will synchronize by new object every time. So it means every method, if everything will go inside this, because we have new monitor every time, I will still have very bad performance because inside the synchronized method, it doesn't work. Okay, I hope it's clear now about the limitation. Yes, this is a definitely big problem, and that's why Project Loom, I believe, is not ready for production because all libraries are not ready for this fix. So let's, guys, please contribute to open source and try to get rid of this synchronized. Okay, now we see how Project Loom works, how it's good, or what limitation it has. But now let's check what we have in other languages. Yes, first of all, the first language what implemented some solution to have some imperative simple code, but to use like asynchronous calls was C#. Somebody says it's F#, but to be honest, I don't know. And they're using the async await approach. It means that if you have like if you have a method that is using some non-blocking code inside and should return some feature, some kind of, you need to mark this method like async. And if you need to get the result of this method, you should run await and get the response. This is an example from official documentation. What does it mean? We want to send the request to some method, not block, but wait for the result, but do not block. And when we have some HTML, we do some processing, some regex. And now we have to use new keywords, async await. And if you have like async here, then your caller also should use async, and everybody should use async. It's okay because it was like the first implementation 15 years ago. It's okay. It's still better than in Java that we don't have even this feature. But it's not what we expect. And the second problem, what if you need to block inside this method? So if you need to block inside async method, it will not work. It's the same problem like with Reactor, because under the hood it works as compiler sees this async await, and compiler just reads this code and it use callbacks. Under the hood, it just change your code from this async await to some callbacks. Okay, now we know about the C#, Kotlin. Kotlin, I would say the same stuff. You have a method. If you inside the method you want to do some non-blocking, you should add this special keyword suspend for this method. And this method, inside this method, you can do some blocking, etc. But it's not a real blocking. Still delay. It's like in Mon and Reactor, you have delay. It's not a true block. And if you need to, encoder of this method also should be suspended. And now you have normal method and suspended method. It's called covering usually, and it has some problems. So first of all, it's not efficient because JIT, or ahead of time compiler, use GraalVM, it cannot optimize your code. For example, this code, it cannot do some inline code, etc. Because compiler, again, when it's compile Kotlin code, it use this method will be written to some callbacks, and we have callbacks, a lot of methods, and ahead of time, like JIT cannot optimize it. That's you can expect some degradations if you have like high CPU intensive stuff with coroutines. You will see big degradation. Yeah, memory again. The memory is bigger because you have like callbacks. You have some kind of continuation, some objects. It's also requires additional memory. And what if you must block? If you need to must block inside, it doesn't work. So it works if you have some feature or computable feature, if you have some external service that can return some computable feature or mon, etc. It's okay. You can easily adopt if you return some result, if you have some SDK or some external library that blocking, you cannot do anything. So this Kotlin doesn't help at all. Yes, and I just didn't discuss it in C# or in JavaScript. We also have async await or promise in C++. Async await is almost the same. So I would say it's coroutines and C#. It's almost the same approach. It's some hidden thread pool. You have like blocking imperative code, but compiler change it into code with callbacks. And then we have another kind of model, a wide thread model. And of course, the best language is Golang with coroutines. In Golang, you can block your code whatever you want. It doesn't have any limitation. You can use native code, C++ code inside. So you can start any thread and run your any thread inside this with blocking and create million threads. I would say it's quite similar what Loom use, but I would say much more difficult way because even these CPU caches can be reused. It tries to the same routine should be processed on the same CPU, etc. It's a lot of features, and there is no any problem with CPU intensive task. For example, if you have a lot of CPU, if you have CPU intensive processing inside the coroutine, this coroutine will be interrupted and the CPU will be shared with another coroutine. So it's like very good solution. And this is the main goal of Golang, was to design the like high efficient like concurrency. Yeah, we have Erlang. So to be honest, I don't have any experience, but I know that it also has this stuff. And also we have a Java, but still preview with some limitations. Okay, yes, now we have some useful links. Please, guys, check this, my Medium blog, YouTube, very interesting articles. Yep, that's it from my side. Thank you. And now go to the questions.
Thank you, Sasha, very much. So, guys, let's do applauses. I will do it for you. Thank you, Sasha. I understand that next time I need to upload some applause music.
Oh yeah,
to have it more audio. So, Sasha, I give you a second for catch your breath and drink some water. So, guys, I want to give you some general information because I see a lot of questions about that, and I think it needs to be covered like disclaimer. Disclaimer from Roma. So, Loom, in its current state, it's preview feature. What does it mean? That means that to try it or to use it, you need to enable it, especially when you start your application. And that means it's not production ready. So at this moment, all this Loom feature is just for you to try it, to test it, to play it, basically do same work as Alex did, and thank you, Alex, for that a lot, and understand how it works and provide a feedback for Java engineers who works on JVM. Any feedback you will see, any problems in your work, and this will make this feature better. What means preview feature in general? That means that in any JDK which will be released anytime, I mean in Java 20, in next Javas, this feature can be changed. So API can be changed, how it's used can be changed, how it works inside can be changed because it's preview feature. Also, we had a question in the chat, when will be it available in the LTS version? We don't know.
Yeah,
so next LTS... Yes. So next long-term support version is 21. We have no information if Loom will be available there. Most probably not. So most probably it's will be available somewhere in the future. So now it's preview feature. It's a huge one. I also see a lot of comments in the chat that it was worked on for decades on this feature, and a lot of things is there. So guys, please don't use Loom in production right now. It's not a good option. It's because you will have a lot of problems with that. So now it's preview feature to try to play with and be ready, be prepared when Loom will be in real life and there. And small addition to that, all libraries before this feature will be really released and become in a long-time support version, I suppose most of libraries or most of main libraries will provide support for it. So right now, yes, a lot of libraries are not, but closer we come there, it will be supported. And one last thing I want to say before we move to questions, guys, if you still use Java 8, you have problems. You have big problems, by the way, because it's already end of life reached of Java 8. So your application are under all threats which can be there, under security threats, etc., etc., etc. So I understand there are different problems, different customers, etc. But please use all your passion, all your braveness to convince to move from Java 8 to Java 17, because end of life of Java 11 is coming this September. So this is something you need to do. Yes, it's painful. Yes, it's needs some effort, and it need your effort for that. But please do that. If you use any Java before 8, same for you. Java 8, 4, 5, whatever. Yeah. So yeah, I understand. I understand different circumstances, but please do that. So let's move to questions. We have a great discussion in the chat, a lot of things and a lot of opinions coming there. So I tried to take some questions to my list, and also we have some questions at Q&A. So I will try to ask them as I take them. So, yeah, the good question. What about MDC? So we had this feature for regular threads. All logs agents are working this. So about this and Loom.
Okay, I believe it's a question about thread local, right?
Yeah, exactly.
Yeah, it's the same problem as Reactor has, or like reactive stuff. So yeah, it will not work. But to be honest, my topic, we covered only one portion of Project Loom, because usually Project Loom, it contains two changes. The first is like virtual threads, and the second one is structured concurrency. And in structured concurrency, they explain how to deal with how to combine together some virtual threads to have a good stack, etc. It's about the same what in Kotlin coroutines you have also like some structured concurrency. But we didn't cover it. But yeah, by default it will not work. So we need some new version of Logger which will support the virtual thread.
Okay, yeah, cool. Thanks for the answer. I forget to mention one thing, guys, because I know that somebody will drop during Q&A session. So first of all, please subscribe in our community on Vera Community and subscribe on our YouTube channel, so you will not miss information about all our events and more people will know about our events. And also after this event, you will receive feedback forms. So I know you don't have time, you are busy, I am too. Please find a couple of minutes to leave a feedback for us. It's really important for us to know what you feel about this session and how we can improve it. Yeah, let's move back to questions. Good question, and we had a great discussion about that. I just want to highlight it on the stream. Question was the following. Why should we consider using Loom instead of tuning and scaling instances on the cloud side?
Yeah, I believe I tried to explain the problem. That's not possible, but still, yeah, the problem is that you cannot, to scale something in cloud, if it's not a Lambda, because you don't need to scale it, it will be scaled by default. If you have like Kubernetes, ECS, like some Docker-based service, with Spring Boot, for example, and you need to specify some scaling policy to explain when the new instance should be scaled up or scaled down. And usually you have to use like CPU, memories, different network, like utilization, etc. So, for example, if you're in with Reactor, usually like 99% of your scaling should be CPU, because it's like it's CPU intensive stuff. And if you use a Tomcat with this blocking stuff, you should maybe you don't have a good simple metric if you what you can take from the Docker, but you can use some maybe in expose some custom metric to see how many blocked threads, how many connections are in block state. I mean, not in waiting state. So if thread pool is full, you have a lot of connections which are in block state. Maybe you can use this metrics, but it will depend on your service. It's like very difficult. It will not be common solution for everything. Maybe for some special service it will work, for another no. So, and you cannot predict. And if you have like external service which is not reliable, it can respond in 1 second, but some days it can start responding in 10 seconds. This metric will not be relevant anymore. So I would say no good metrics for scaling. That's why in cloud, even with this solution, you cannot deal with it. Yeah, you can try to start like 100 million threads. And the problem is that every thread takes 1 megabyte memory. It will require a lot of memory. It will be you must to start a very huge EC2 types or like servers with a lot of memory, but still, even if you have a lot of enough memory to start all the threads, you have operation system limitation. It cannot create like a lot of threads. I believe it's 64,000 is something maximum, but even with the 64,000, you will have a problem with context switching. It still will be slow. And the answer, no, it's not possible.
Yeah, and also I would just provide a comment from chat, which we had in this discussion, that it's a question more also about cost. So if you will just scale your cloud application and just run more instances, it will cost you. So here we also try to...
Right. With this approach, you can use 90% of CPU and can process more requests per second when with normal Spring with Tomcat blocking.
Yeah. Also, yeah, I want to maybe highlight one thing, maybe have a small discussion, Alex, with you. So the question was like not a question, but also a discussion like. So looks like a common problem with all these threads and all this stuff. So maybe Spring has some solution for that. So we don't need Loom, and Spring already implemented that. I have answer for that. So basically, Spring invented, not Spring invented, but Spring inherited inside WebFlux. WebFlux was the solution for this thread problem. So the problem for thread starvation and the problem of not good ability to reuse these operation system threads. So WebFlux was introduced, and all reactive programming was introduced. This is a solution from Spring.
Yeah, and we advocate for this, so. Right.
Yeah, so I don't want to advocate for that. I'm just saying that, yeah, this was the solution, and now it also has its own limitation, which Alex already covered in presentation. So now we have a solution or more base level from GVM. Okay, question from Victor. How garbage collecting and garbage collector itself is working with virtual threads?
Yep. So as far as I know, the G1 at least can process virtual threads, no problem. But how it works? So virtual threads, it's just an object, right? This object is stored in heap, and there is no difference between your object or virtual thread object, because virtual thread has some kind of continuation, a lot of internal stuff, but it's still the object. And if we have like GC root, we can trace it. So I don't see any problem. Fortunately, I don't have a big experience with implementing this garbage collector, but at least I don't know about any like big problems. So
yeah, also I would say, as this feature is from the core of GVM is coming, I suppose they would adopt garbage collectors to work with it. So that's not an issue we should care of. Question from Veronica. How does the process define the number of operation system threads to use? Do you configure it, or is it calculated, and what is the default behavior?
Okay, good question. So I believe this is a question, how many system threads processed in a virtual thread, right?
Yes, exactly.
So like, by default, it's user. I'm not so confident, but I expect that it uses the same number of threads as the number of cores as usual. Like, for example, Reactor use it, but you can override it. But there is some special stuff that in some piece of code, Java, even in JDK, there is a change that if we have some blocking code inside, they can create, you start virtual thread, it does something, and then in this virtual thread can produce new system thread for some special corner cases. I cannot take the sample, but in presentation, what I have a links, and this link has some presentation. There is some sample when special for some corner case, new system thread will be started and will process it. For example, in Golang, when they have native code invocation, they also like create new system thread that will do this native code invocation. It's like some special limitation, but looks quite similar what Java does. So by default, it's the same number of threads, but there is some special cases when new thread can be created specifically for to have some space.
We have a comment on our previous question regarding garbage collecting, so I want to read it. Virtual threads garbage collecting was not an easy problem to solve because they remove objects from the stack, which means potentially losing their only live reference. You can read about the topic, it's very interesting. So Lauren, thanks a lot for this comment. Yeah, I would say we would have a lot of talks, not only on our channel, but also all around the internet regarding Loom and how different aspects of it works. So yeah, guys, stay on track. I suppose a lot of interesting discoveries would be there. One more question. I think it's a good question for a good starting of a discussion. So your example shows way to spawn a new virtual thread for every request. Doesn't it create overhead on memory to create these many objects? Can we reuse these virtual threads?
Yes. Definitely. So this is like the simplest. Yeah, I just show this what we can do, but it's definitely not a good sample. For example, if you have some requests which are processing CPU intensive stuff, then you have some requests, not requests, like methods, like your get post method. Some requests are processing some I/O, and now we are moving everything to virtual threads, and every request will be processed by virtual thread. It's not okay, right? But I just highlighted how it's easy, but it's not okay. And now you can just, in some piece of code where you're doing some blocking code, you just can, this blocking code easily, only this blocking code move to the virtual thread, for example. You have a normal code, then you have blocking with, I don't know, HTTP call blocking, right? With like REST template blocking. You can run it on a virtual thread pool and press join, like block, and it will be blocked, and then go next. So ideally you shouldn't differentiate it, but because we have a limitation with Java and this. In Golang, for example, you can do all and don't expect any problems.
Question from our YouTube chat from Vadim. So what about the priority in threads? How does it work with virtual threads?
Okay, I cannot answer. I don't know.
Well, I think I have an answer for this one. So the idea which Java developers, JVM developers, has in their mind when they develop all this Loom feature was the following. Everything should work as it worked with previous threads, like as before, but now threads should be lightweight. That's why this feature was developed by decades, and that's why it takes so many effort to bring it, and that's why it's still in preview feature to check all corner cases in different aspects how it could work. Thing is that all the things you get used to for normal threads, which we have from Java, I could not remember the version from which Java do we have them, same thing should be here with virtual threads. Except the one thing, how you instantiate them. So now you instantiate them then with new thread pool executor, or with like new thread, not new thread, but new virtual thread. So this is the only change they tend to have here. Of course, some things which happens there and there, like local thread variables, etc. But still, the intention is that everything should work as you expect it to work, and don't need to learn new stuff from scratch. So I think this is the answer. Okay, basically we run out of questions. I will ask the last one. We have discussions about that all around the chat. So you showed us 3 approaches basically, right? So first one is classical one with operation system threads. Second one is reactive approach with WebFlux, and third one with Loom. I will skip the combination of WebFlux with Loom because of course we will have so these 3 approaches. Let's imagine a world in, I don't know, 10 years or 15 years when all of these will be production ready and all developers will be able to use any of this feature. In your opinion, which one will be dominating one?
I hope Loom will be dominate, because it depends on the system, but because, for example, reactor or reactive system, it has another feature like back pressure, etc., right? But if you have REST service, back pressure doesn't work, right? Because your client there is communication HTTP doesn't support. But if you have some WebSocket special or AirSocket, you still need to use WebFlux, right? Because it has some special features for it. But for simple REST calls, I don't see any big advantages of RxJava. Only that it's stable and we have it right now, right? But it's not so easy to implement it, to debug it. And plain old code is much more simpler, I would say. And if Java community can get rid of all these limitations, this definitely will be better than RxJava or React.
Great. So thank you, Alex. Thank you very much for your presentation, for your work. It's just amazing. So applause from my side, and also a lot of applauses were there in the chat. So thank you very much. Guys, I want to thank you all again for being with us here. I hope you love this webinar. So we are waiting for your feedbacks. Please subscribe for our channel, subscribe for our community. We're really glad to see you here and on our future webinars. A lot more coming. So hope to see you there. Our speaker today, Aleksandr Filichkin. Alex, again, thanks a lot.
Thank you. Thank you, Roman.
Yeah, and also subscribe for Alex's blog. The link to his blog is in the chats. He wrote a lot of nice things here and writes still. My name is Roma. I forget to introduce myself in the beginning. So I'm the host of JACOVCommunity. Nice to see you here. See you on future webinars. Have a good rest of the day and bye.
Thank you. Bye-bye.